Okay, the third video in this statistics series is over set notation. So this is going to be basically just a quick summary of some fancy symbols that you've never really, I don't know if you've seen before, you might have, but at least sort of showing you what they are, explaining what they mean, and well, hopefully it all goes well. So set notation. Here are these symbols that I'm referring to. So the symbol that looks like a U, it's not a U, but it kind of looks like a U, right? That's called union. And another way of referring to this is not called or, but when you're reading some sentences out, and the word or comes up, we kind of think of union. So anyway, bypassing that for now, this symbol combines all the elements of one set with another set. So union is bringing all the elements of one set to another set. So an example, let's say I have, we'll call a set with certain numbers. We'll call a set, we'll say it has 2, 4, 6, 8, 10, right? We'll call this set is called A. And then I'll make another set. We'll call this set B, and this set will have 1, 3, 5, 7, 9 in it, right? If I were to say the union of A and B, so A union B, then I am combining all the elements that this set has with all the elements that this set has. So that set would, of course, be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, because I'm using all the elements in here, which are the odd numbers, and then all the elements in here, which are the even numbers, and putting them into one set. So it basically would be all the numbers between 1 and 10. That's what union means. It means bringing all the elements from one set into another. So the next symbol is the upside down version of that, which is called intersection. And this is kind of the word and. Again, we'll skip on that for now, but intersection. So this symbol means only the elements both sets have in common. So let's say I have a set A, and we'll use letters this time. Let's say this set is A, B, D, F, and J or something, right? And we'll say B is the set A, C, D, G, and F. The A intersection B, meaning this is a set that has any values that are both in A and in B. So it's not combining all the elements of A with all the elements of B like union does. It's only taking the ones they have in common. So both sets have an A in it. So this set would have an A in it. Both sets have a D in it. So this set would have a D in it. And then both sets have an F in it as well. So then this has an F in it. So this is saying the intersection of A and B is all the elements that A and B both have in common, which in this case would have been the lowercase a, D, and F, because those elements are in both sets. The next symbol is subset. So this is to indicate that all the elements in one set also belong in another. So let's say I have this set that's A, B, C, D. We'll just say A, B, and C for now. Keep it simple, right? And let's call this set, I'm not going to call it B, we'll call it U. We'll say the set U is A, B, C, D, E, F, G, right? I can say that A is a subset of U because all the elements that are in A are also in U. Like a subset means a set within a set. So the set A is inside this set. All the elements in A are also in this set U. I don't know if I said B a second ago, but all the elements are also in U. So it's a subset. Another subset of U, you can really make any combination of these would be a subset of U. So I can make the set, I'll call the set B, and I'll say that B is A, D, and E. And B would be considered a subset of U because all the elements in B are also in U. A, D, and E are also in that set. To give you an example of something that wouldn't work, right, we'll say set C is the set X, Y, Z. C would not be a subset of U because these elements that are in C did not come from U. Those elements are not in U at all. So that's an example of not being a subset. And then the last thing, which really kind of should be first, I've mentioned this word already, but this E stands for element. So element describes something that's within a set. So for example, if I call the set A and I say the set A is 1, 2, 3, 4, 5, for example, then these are all individual elements of that set. So I can say, for example, that 1 is an element of the set A because 1 is indeed an element in that set A. 2 is also an element in that set A. So 2 is an element of A, right? I can say that for 3, 4, and 5. 3 is an element of A, 4 is an element of A, and 5 is an element of A because those are all in that set. But 6, for example, is not an element of A because 6 is not in the set A. So I would denote that as an E with a little line through it. Okay? So that's what all of these mean. If you want to recap, you can rewatch that if you need to. But let's look at these examples and say if it's true or false. So true or false, 5 is an element of the set all odd numbers. So if you think about all the odd numbers, is 5 an element of that set? Well, this set would be, I guess not including negatives right now, which we probably mentioned if it's negative or positive, but still. The set would be 1, 3, 5, 7, 9, 11, 13, etc., right? It would go on forever. So these are the elements within that set because these are all odd numbers. 5 is definitely an odd number. 5 falls within that set, so this is true. 5 is an element of that set. Okay, now not necessarily math related, but it's still logic related. Friday is an element of the days of the week. So this set here, if I were to actually write it all out, this set would be Monday, Tuesday, Wednesday, right? I would have all the numbers or all the days of the week listed out. Of course, Friday would be included in that list. So Friday is indeed an element of that set. Friday is a day of the week. So that would also be true. All right. T is not an element of the set letters in the word yellow. Well, that set would be Y, E, L, O, and W. We don't have to write the L twice to indicate that it's in the set. The set has L in it. T is not an element of that set because T is not in the word yellow. So that is true as well. T is not an element of that set. And remember that this had the fact that it said not an element to begin with. So that's true. It's not an element. Number 4, ABC is a subset of A, B, C, D, E. And to be a subset, all of these elements would have to also be within this set. And you can see that they are. All the elements here are within the bigger set as well. So that is true. ABC is a subset because all these elements are also in that bigger set. All right, let's look at number 5. 1, 3, 5, 7 is a subset of 1, 2, 4, 5, 6, 7. So the question is, are all these elements in this set too? And the answer is no, because 3 is in this set, but it is not in this one. So this is not a subset because not all the elements here are within this, what we can call, I guess, the bigger or mother set, if you want to. So that's actually false. That is not a subset. So the numbers 1 through 10 is a subset of all even numbers. So this set, all even numbers would be 2, 4, 6, 8, 10, etc., obviously. And this set, numbers 1 through 10, of course, be 1, 2, 3, 4, 5, etc., up to 10. So this is not true. This is false because this set has 1, 3, 5 in it. And of course, it's got all these other odd numbers. And these numbers are not included in this bigger set over here, all the even numbers. So this is not a subset because there are elements here that did not come from this set. So that statement there is false. Okay, now to give you a visual representation of this, intersections and unions of sets. So this is already illustrated for you, but let me kind of walk you through. I might even just recreate this. So let's say we'll call this set A. A is the elements 2, 4, 6, 8. And B is this set. B is 4, 6, 8, 10. So in this, I guess I'll just use this illustration. In this illustration, this right here, this circle is A. And you can see it has 2 in it, and it has 4, 6, and 8 in it, because those are all within that circle, right? As denoted, A has those values. Let me use a different color. B is this circle here. And you can see that B has 4, 6, 8, and 10 as well. So all those numbers are within that blue circle. So they're in that set B. Now the intersection is only the values they have in common. So you can see the intersection, and why it's called the intersection, is where the two sets overlap. A and B overlap. What do they have in common? They both have 4, 6, 8 in common. That's the intersection. So those values are shared between them, which is why they are in that overlap area. So that is the intersection of A and B. Okay, now similarly, the union, so let's say A is, we'll keep it actually, we'll use the same colors. So red for A. So A is the set 1, 2, 3, 4. So you can see A is right here. It's the numbers 1, 2, 3, 4 in that set A. And B, we'll call this B. B is 3, 4, 5, 6. So you can see right here, this is set B. It's got 3, 4, 5, 6 within it, right? Union means bringing all of them together, all the elements in A and all the elements of B together into one set. Now you might notice both sets have a 3 and a 4 in it. We don't have to write the 3 and 4 down twice. We just need to indicate that it's there. So you can see the sets include 1, 2, 3, 4, 5, 6. So union is, you can see it's shaded all of A and it's shaded all of B because we're bringing all of them together. It's not just the region they overlap. That's, of course, part of it. But the intersection, or not the intersection, the union is bringing all these elements of A and all the elements of B together into like one big happy family. So all of them, 1, 2, 3, 4, 5, 6, are included in that set. So intersections and unions. So let's identify a little bit here. A intersect B. So I'm going to use colors. This might make it helpful. So A is this circle here, the red one. And B is this one here in blue. So the intersection, right? The intersection is what both have in common. So the overlapped region of A and B, I'm going to use, I guess, orange for this. The overlapped region is here in the middle, which is 6 and 1. 6 and 1 are both inside A and in B. So the answer to this set would be, let's go back to this, would just be the set 1. I'll put it in numerical order, 1 and 6. 1 and 6 are the values that A and B both have in common. So A union B, what is this set? So that's all the elements of A brought together with all the elements of B. So all the elements of A are 1, 2, 3, 5, and 6. And they're all right here. And I'm just looking at them out of order. But it's 1, 2, 3, 5, and 6. And then all the elements of B as well. So B has 1 and 6, which I've already included. But B also includes 4 and 9. So 4 and 9 are also going to be in this set. It's typically better if you write these in numerical order. So I'm going to just go ahead and fix that. 4, 5, 6, then 9. So all the elements of A brought together with all the elements of B. So everything that's in these circles, which would be, I guess I'll use purple. Everything inside this like 8 shape, right? All those elements are in A and in B. So that is a union. Now, 3, A intersect B intersect C. So that's saying it has to be in A, and it has to be in B, and it has to be in C. So let me go ahead and shade C in with this green. So we're looking for the intersection of A, B, and C. So the overlapped region for all three circles. The only place where all three circles overlap is right there in the middle where that 1 is. So A intersect B intersect C is just 1. Just that number 1, since 1 is that number right in the center. Now let's look at the parentheses. The parentheses can make things a little bit tricky, but not too tricky. All right, so we just have to do the parentheses first. So A intersect C. So let's look at A intersect C first. So that's the region where A and C overlap. So A is in red, green is in C, or C is green. The overlapped region between red and green is right here. It's the 1 and the 5. I'm going to circle that in like black so you can really see it there. That is A intersect C because that's the overlapped region where A and C are. And then it says union B. So I'm going to bring all the numbers that I have here, 1 and 5. That's my set for A intersect C. And I'm going to union it with B, so all the elements in B as well. So I'm going to take that and put it with all the elements of B, which is going to be adding a 4, a 6, and a 9 to this as well. And of course, it's nice if you put these in order, so I'm just going to put these in order. We're good. And so hopefully that made sense. I looked at A intersect C, which again is this overlapped region here, the 1 and the 5. And then I unioned it, so I took that 1 and 5, and I combined it with everything that was in B, which is 1, 4, 6, and 9. I didn't, of course, have to write the 1 twice. So I just write it once and I'm good. But that's that, I suppose. Okay. And then the last one is C union B. So that means bringing all the elements of C and all the elements of B together. So the elements in C are 1, 4, 5, 7, 8. So 1, 4, 5, 7, 8. And all the elements of B are 1, 4, 6, and 9. So I've already got 1, 4 listed here. I won't write them again, but then we have 6 and 9. So there's your answer. And again, it's probably better if you put them back in numerical order, but I'll leave that alone for now. So that's intersection and unions. So one more, intersections and unions, but now with pretty much the same thing, but with names. North, union, south. So everything in north combined with everything in south. So everything in north would be Carol, Mike, Jack, Fred, and Jill. Jack, Fred, and Jill. That's all the ones in north combined with, because it's a union, all the ones in south. So south is Fred and Jill, which I already have, Bill, and Lamar. So that is the union of north and south, all of those names right there. I'm going to erase this because it's going to take a lot of space. So then the next one is south intersecting east. So where does south intersect east? So south is here and east is here. So the intersection is there, the little football-shaped oval. Fred and Bill. Fred and Bill are the only ones that are both in east and in south. Fred and Bill. It's the only overlapping region of south and east. Fred and Bill are inside both those circles. All right, so north, union, south, union, east. So bringing all of north with all of south with all of east. So it's everything in north, which is with everything in the south with everything in the east. So that's literally every single name. Because it's not the intersection. It's not where they all overlap. If it was the intersection, that'd be different, which is the fourth one, which we'll get to that in a minute. But the union is just all the ones in north. So Carol, Mike, Jill, Fred, Jack. With all the ones in the south, which is Jill, Fred, Bill, and Lamar. Which we already had Jill and Fred before. With all the names in the east, which is Jack, Fred, Bill, and Kate. All those names together. Just don't have to write the names twice. So it's literally every single name on here. That's the union. Now the intersection is different. The intersection of north, intersection of south, intersection with east. So It's where all the circles overlap. The only place where all 3 circles overlap is Fred. Fred is the only person that's in all 3 of those regions, territories. So Fred is the only one in that set. And then we have east intersect north, union south. So we're going to look at the east intersect north first. So where does east intersect north? So intersect is the ones they have in common. So the only ones they both have in common are Jack and Fred. So that's Jack and Fred. And then it's union with the south. So we're going to combine those names with all the south names, which is Fred, Jill, Bill, and Lamar. Now we already have Fred, so we're just going to add Jill, Bill, and Lamar. And that would be the answer for number 5. That's going to be it for the set notations. It can be kind of confusing at first, but I think if you're able to watch the whole video, I think it started to make sense a little bit near the end. If it doesn't, just ask me and I'm happy to help. But that's going to cover it. Next video, we'll talk about probability.